Hello, welcome you all. It's a long gap due to some issues. It's okay. Let's begin. Today we are going to see about an important and necessary mathematical instrument. First, we want to know something about that. Before that, what's your height? We can able to say just for example taking me 177 centimeter. How can I say it's easy to measurable my height? If it's 6 feet height, I can able to measure. Maybe 10, okay, 20 feet, okay, I can able to measure using a ladder and a measuring tape. But above the certain limit we can't able to measure some height. And also in some places we can't able to measure the distance. If we are able to measure the road distance between one place to one place in road, but we can't able to measure in water. How can you measure that in water using measuring tape? No, not possible. And in air, how can you measure in air? If a flight is flying, how can you measure that flight? That is the distance between where you stand and the flight where that flight can't able to measure. Even though if we take sun, the distance between you and the sun, how can you calculate? It's unimaginable. We can't able to do a direct calculation, but indirectly we can do using some instruments. Like that, I am done a model with one of the instrument for these purposes. This was introduced by a scientist in 19th century itself. The name of the instrument is clinometer. Basically, this instrument is used to find the angle of inclination and angle of depression in mathematics at trigonometry. You know trigonometry. Sin theta, cos theta, tan theta, that's the trigonometry. Okay, let's begin this. The application of this clinometer is vast in nature. Here, I take upon two situations, that is the rare situations, and after that, I am explaining a big, very big situation, that is the measurement of sun from where we stand on the surface of the earth. First, we done this, and with this basic knowledge, we proceed with that sun experiment. So, this is clinometer instrument, and this is the land and that is water. Okay, this is the protector, you know, and this is used to measure the angle. This is the telescope. This is the miniature model of clinometer. So I done like this, and we can able to move this, and we can able to move this. This is to indicating the angle. Okay, first we measure angle of inclination of an aeroplane. Okay, first we can adjust. I take this as my eyesight. Now I am seeing through telescope. It's straight, and then slowly I can seeing the aeroplane. Yeah, I fixed that. Wait a minute. I fixed that, and I want to note the angle. You see, 10, 20, 30. It's a 45-degree angle. Okay, and the distance between distance between me and the vertical distance of that aeroplane on the ground is 28 centimeter and the angle is 45 degree. With this I can able to find the vertical height of an aeroplane which is fly. It's 28. I can use basic mathematical formulas of tan theta. Tan theta is equal to opposite by adjacent. With this I am substituting the values of theta is 45 and the adjacent side measurement is 28 centimeter. We want to find the opposite side measurement. It's being 28 centimeter. When we take scale and measure it, accurately it shows 28 centimeters. And then the same concept we done in that ship on the water. So I will turn and place there. You see it shows 15 centimeter. So 15 degree. Tan 15 value 0.268 and the height of this is 7 centimeter. With this the basic function tan theta is equal to opposite by adjacent, substituting theta value 15 and the opposite side value 7 and finding the adjacent side value, that is the distance between me and the boat. We can't able to measure in water or ocean, so we use this to find it's 26 centimeter. The distance between me and the ship is 26 centimeter. So with this instrument we can able to measure this type of things. Now let's come on to the example of sun. So consider this as sun. Okay, consider this as sun. I am standing here one point on the surface of the earth, and with this I am measuring this, and consider I am standing other side like there, and then I am measuring this. With this I am framing a triangle shaped, and then I will taking midpoint and connect that. It will become two triangles, and then taking midpoints I will find the center line of the sun. With that, either this side or this side I will take single triangle. With that I am solving. I know, okay, what I know, the distance between me and that center line and the angle. With these two, using tan theta, I can found what is the distance of the sun from the earth. The scientist found 1 astronomical unit is the distance between us, distance between people on the surface to the sun. This using this clinometer, some of the mathematics interested students done an experiment to find the distance of the sun from the earth. They found nearest values because some errors. In clinometers there are some important factors which affecting the result. What are that? First one, we want accurate angle measurement. Second thing, accurate values. Third thing, accurate calculation. If we done this three correctly, we can able to find things rightly. Thank you. We can meet soon. Bye bye.